Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about reverse linked list second problem of the LeetCode, and its index is 92 and the problem is of medium type problem of the LeetCode. Okay, so given the head of a single linked list and the two integers left and right, where left is going to be like less than equal to right, to reverse the nodes of the list from the position left to position right and return the reversed list. Okay, so basically we need to just reverse the some subsegment of this list. Okay, that is, you can see if you have been given sum 2 and sum 4, that is the position of the node this one and position of the node this one, we need to reverse the entire segment. You can see we are not going to reverse the entire linked list. Okay, we can reverse the entire linked list if left is given as 0 and right is given as the end of that is the end of the linked list. You can see left and right are basically the numbers. Okay, and if left is like 2, we are going to just fetch the second node from the start of the linked list. Okay, and if similarly if right is going to be the end of the linked list, then we are going to just move to the end of the linked list, and then we are going to just reverse the subsegment starting from left up ending up to the right. Okay, so this problem is a little bit harder than the reverse linked list first problem. And in the first problem, we need to just reverse the linked list, that is from left equal to 0 and right equal to n minus 1 if there are n nodes present in this linked list. Okay, so what we have to do, n is like 500, nodes values in this range and left is right, and there is a follow up also. Could you do it in one pass? That is, just iterate exactly one time starting from I equal to 0 up to I equal to n minus 1, where n is the number of nodes present in this linked list, and we need to reverse the segment starting from left and ending up to right, both inclusive. Okay, so how we are going to do that? Okay, so no need to worry about this, is just a modification of the simple problem reversing a linked list. Okay, so first let us understand how to reverse a linked list efficiently, then we will together move on to just find out how we can reverse a linked list starting from this left bound and ending up to this right bound only. Okay, so let's move further to first understand this concept reversal of a linked list. Okay, so I have here maintained a linked list. You can see the arrows are going to denote the pointers, that is the next pointer. You can see there is a linked list containing the value of node as 1, and similarly the up to the 6. Okay, so if we need to reverse this entire linked list, suppose for now we have been said to reverse this linked list so that our new linked list becomes 6 to 5 and 5 to 4 and 4 to 3, then again 3 to 2 and again 2 to 1. Okay, so if we have been set to reverse this linked list so that the new linked list becomes like that, now just I have drawn. Okay, so if we have been asked to do so, then how we are going to do that in the best possible way, starting from the beginning and up to like starting from the beginning, and we need to do in only one pass. One pass basically means start traversing from this head of this linked list and stop iterating up to this final position, and that is the only thing that you are going to do, and after doing this you must have a reversed linked list. Okay, so how we are going to do that, let's understand this now. Okay, so one thing two things that you need to maintain, and what is that two things? So let's call it as previous. Okay, so I will maintain some previous value. Let's say previous is initially initialized as null, and I will also maintain a current. Okay, so current is going to be like that, which is going to be iterated in this linked list. Okay, so current is used to iterate in this linked list. So I will initialize with this head. Okay, so I will start writing some type of for loop conditions. So let me write down over here. Okay, so I will write while current is not equal to null. Note that this condition I am writing it over here is for reversal of a linked list. Okay, so two things that you need to do is like so for now, suppose you are at this position and you need to reverse. Okay, so not talking about this position now because this may confuse you guys. Okay, so suppose at a certain step of iteration you are at this position and previous is this position, right? Previous is going to store the previous node. Okay, so if I am at this position, my previous would be null. Okay, so suppose this is the current position and this is the previous position, and you need to reverse this arrow, right? So how you're going to do that? Okay, so you can easily do that by you can easily say that I will reverse this current next arrow. You can see this is the arrow. I need to reverse this arrow such that this arrow will not point to the next one. It will point to this one. Okay, so how we are going to do that? We can easily do that by changing two three conditions. Okay, so if we reverse this arrow to this position, then how we are going to move forward to this next node? For moving forward to the next node, you need to store that node. Okay, so you have to do one thing, and what is that one thing? Now let's understand that. Okay, so let's say I'm going to make another node temp as, which is going to store currents next. Okay, so here you can see 3 will be stored, right? So if 3 will be stored, I can make now as current, that is 3 node with value 3 is now our new, that is the next node that we will start taking care for. Okay, so for now I'm going to reverse the arrows, right? So current next should become previous, right? So you can see this arrow is going to be reversed to showing that this current is pointing in the leftwards. Okay. Now you can see my previous should also be modified for the next iteration. Previous becomes current. You can see previous becomes 2 and current is next is previous, which is already assigned. And now you can see for the next iteration I need to do one thing. And what is that one thing? From the next iteration I have to start with 3, and you can see 3 is stored in temp, so I will assign current as temp. So if all these sequence of steps are right, let's say we will have, okay, so let's say let's validate this condition, right? So you can see if I will take as current as this one, previous is null, so 1 is pointing to null. Okay, okay, so not doing like that, I will use these steps. So current is pointing at now this position, so I will store temp as 2. So using this temp variable is nothing but basically keep tracking to a certain node, such that because we are going to just change this next pointer of this current. So for by changing the next pointer of this current, how we can move forward? We can move forward by only and by pre-storing the next pointer of the originally linked list. Okay, so temp will store 2, and you can see the current next becomes previous, but you can see that there is no left node present over here since previous is null, so my current next would null become null. Okay, so this is basically 1 will point to the something null value, and you can see previous becomes current, so my previous is now 1, and what is my current becomes 2. You can see at the next step of iteration, while current not equal to null, current is now pointing to this position, that is current is now at this position. So it becomes easy that if each and every time I will move forward to the next position, next node, and so on until we reach the end of the linked list. Okay, so if I will show the validation of the second step, it should be like temp would be stored 3, right? And current is 2. 2's next would become previous, so it would become, you can see 2's next would become 1. You can see the linked list is going to be reversed, like null 1 2, all the arrows are now pointing in the opposite direction. Okay, and now previous will be assigned as current, so previous will become 2, and current would be assigned as temp, so current would become 3. And now the next step of iteration starts with 3. You can see the sequence of steps, everything is going fine smoothly, arrows are also going to be reversed. So these 4 lines of code is going to be like helping us in very useful manner. Okay, now moving further to our original question, how our original question is going to like slightly different from the previous question, like a reversal of this entire linked list. Where in this like in this current problem, we have been given some left and right bounds. How we are going to modify our code to give the correct answer for this problem? Okay, and it should be like best code. Okay, so let's move further to understand this. Okay, so we will be given some left bound and some right bound. Okay, so what I'm going to do is just start, that is just take some variable current and just start iterating in the linked list, like in this one, start iterating in the linked list. And whenever you found the, also I need to maintain some count variable, that is the number of nodes visited so far. Count will be initialized as 0, and I will run a looping condition while current is not equal to null, that is until we reaches the end of the linked list. So while current is not equal to null, each time I will increment my count. Okay, count plus plus. Okay, and what is the need of maintaining this count? You can easily see that whenever count will be exactly equal to left, it means that this is the point where we need to start reversing my linked list. Okay, so this is the point where we need to start reversing my linked list. So I can say reversal of this linked list starts from here. Okay, and if the reversal of linked list start from here, the entire code remains same, like of this position. Okay, and after doing this, that is we reaches the, that is count reaches the exact value exactly equal to right. Okay, then I need to assign my current exactly equal to the position of this right plus 1. And the reason is very simple, we are following the O of n, that is could you follow this question, that is could you complete this question in one pass and in time exactly equal to O of n. That is why I'm assigning my current exactly equal to position of this right, that's the node address of this right bound, plus 1. Okay, so the all the steps are going to be like very much simpler. And if you're not understanding this still now, no need to worry about, I'm going to explain this again while showing up my code and what are the things that I have done over here. So if count is exactly equal to the left, start reversing the linked list until we reaches the count exactly equal to the right. Okay, and if all the reversal happens, we need to just adjust the pointers. Now how we are going to adjust the pointers, let's understand this with the help of diagram. Okay, so suppose okay, so let me first erase this stuff, so because it is creating, it might create some confusions, right? Okay, so I have erased some values. Okay, so this part of code remains same. Okay, so let me do one thing. Okay, so it is almost done. So let us keep this. Okay, I think I have done something. Yes, it is fine. So let me do one thing. I will just clear this. Okay. So what I was saying like that, suppose we have to reverse this piece of linked list. Okay. So whenever my count becomes exactly equal to 1, sorry 2, because this is 1, this is 2. So whenever my count exactly equal to 2, I will start my reversing my linked list. If I will start reversing my linked list up to this position, you can see I have to adjust, that is my new linked list for this segment would be like 4, 3 and 2. My new linked list would becomes like that. Okay. So now you can see I need to adjust the pointers. Like so 1 should be pointing to 4 and 2 should be pointing to 5 and 5 should be again pointing to 6, and if there are more nodes it should be pointing to that. So the only the tricky part is like reversing this linked list and adjusting this pointer. Okay, so this can be easily done by maintaining some previous variable globally for this entire linked list. Okay, so it can be easily done with the help of maintaining this variable. And I'm going to explain this how I have maintained in the coding part. So let's move further to understand this entire thing in the coding part. Okay, so let's move further. Okay, so I think I've submitted some code. You can see as modifying my code to such an extent I have got some 0 ms code. So let us look over that. Okay, so you can see I have taken the current as head for iterating in the list, and this previous is null for globally, that is for our given linked list. This previous was for maintaining that, not for the reversal of the linked list. This previous is for the maintaining the previous node of the this original linked list. This is initialized with null tracking previous node in the list, and this is count helps to find the left and right position in the list. So while current is not equal to null, increment the count. If count exactly matches with left, reversal of left to right starts. So I have just take inner current as current and inner previous as null, because this is going to be like reversal of this linked list. While count is less than equal to right, just take the forward node and just the exactly same thing that I have done for the reversal of this linked list. You can see inner current next is inner previous, then inner previous is in inner current, and inner current is initialized with forward. Now the reversal ends over here. Now we have to adjust the original list. If previous is not equal to null, check left must not start of the list. Now this is going to be like very much important. Okay. Now for now you just ignore this else part condition to understand this. Okay, so suppose and also you must ignore this previous one and else part. Only thing that you need to understand for now is previous next exactly equal to inner previous. Okay, so let's understand this. So after the reversal of this linked list, you can see my inner previous would be at this position. So let's denote as prev, and my what is the new variable, inner current. So my inner current will be one more than this position. You can see that what I've done is previous next is inner previous. So when this was my current initially, when current count becomes exactly equal to left, I am going to that is my current will be pointing at this position, and my global previous is at this position. Okay, so I need to just reverse the pointers, right? So you can see after reversing this 2, 3, 4 segment of linked list, it becomes 4, 3, 2, and once one is pointing to 4, that is you can see this one is that is this previous is pointing to inner previous. If you look over uh, like if you look carefully over there at the variables, previous is pointing to inner previous. That is what I have done is previous next is pointing to inner previous. Now the thing is like suppose that left is exactly equal to left is exactly equal to 0. Note that I am taking a 0 based indexing type. Like if it is 0, it will denote start of the linked list. If it is 1, it will denote this position of the linked list. Okay, it doesn't matter. It depends upon your choice. But one thing that matters is your understanding towards this problem. Okay, so if left is 0, there might be chance that previous remains null. In that case, your head pointer changes. So you need to take care for that. If previous is not null, just do this. Otherwise, head equals inner previous. And you can see currents next is inner current. And what is this current? Currents next is inner current. That is, if this iteration is done, my current would jump directly to this position. Okay, and that is all these positions have been already iterated and reversed, and current exactly equal to inner current. So I need to use the continue statement because If this statement again happens, then it will give us the wrong answer. Okay, so everything is done fine. Okay, so finally return the head as your answer. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.